Doctor. My name is Mai Jing. Today, we'll have the presentation on our group project. The title of the group project is Reheatable Thermal Flask. The problem that found among the user is that they are difficult to maintain the temperature of the drinks as the temperature will lose when the time passes. The drinks was also not warm enough when the user stay at a cold place, for example, Genting Highland. The next slide illustrates the current thermal flask, which has the insulating storage vessel, which remain the hotter or the colder than the flask surrounding, and the silver coating will help to prevent the heat transfer by the radiations. The thinness of the glass wall will help in stopping the heat from entering or leaving the flask by conductions. And lastly is the vacuum between its double wall. It helps in preventing the heat moving by the convection. The objective of our group project is to design a thermal flask which is able to reheat the cold water until the maximum temperature of 80 degrees Celsius and to maintain the temperature of drinks at the warm temperature. It's also designed to enable the customer to make the drinks when they are not around in the house. Here illustrates the proposed solution of our group. There is a built-in heating system which enables the user to heat the water filled to the maximum temperature of 80 degrees Celsius, and the design also installs the temperature and power indicator, which enable the user to observe the temperature and the level of power left. Besides that, the vacuum insulation will help to maintain the temperatures, and there is a hidden compartment which enable the user to put the drinks powders and allow the powders mix with the water to make the drinks. And for lastly, the rechargeable with USB port will enable the user to charging when they are not around in the house. The right hand side figure shows the design of our thermal flask. And the material used is the stainless steel 304 sheets, digital water temperature indicator, USB connector, heating element, rubber, polyethylene, silver sheets, and also the battery level indicator. That's all from me. Thank you.
So, hi Doctor, my name is Chong Yao Lun from Group Power 5. So I would like to present about the manufacturing process of the thermal flux. So first of all, one of the manufacturing process will be the explosion process. This process is used to fabricate the flux body. There will be a drawing process to stamping out the bottom parts of the flux. And then we will weld it together, form a bottle shape. And then we will weld the both inner and outer parts of the bottle. After welding, they will have a vacuum injection process in order to insert the vacuum in between two inner bottles and outer bottles. So after the vacuum is injected, we will have a temperature testing for the function of the vacuum flux. After the testing, we will finally come out with the polish and cleaning process. So on the other hand, there will be another process for top section of the thermal flux, which is the injection molding process. And finally, there will be a coating within the thermal flux with the reduction agent. So in order to perform the function of the thermal flux well. Manufacturing of thermal flux, there will be a two process for that. First of all will be explosion process. Explosion process is the injection of large amount of water with high speed and pressure in order to form the shape of the bottle. So the machine that we require for this process will be a hydroforming machine. So the picture shows that is a hydroforming machine that used in the industrial, and then they have an accuracy up to 0.01 mm. It is suggested for the application of formation of the bottles because the water pressure that we apply can up to 100 megapascal on the bottles. The next one is the machine of vacuum injection process. So vacuum injection process, we have a machine for that to allow the vacuum inject in between the both bottles. So the vacuum injected is to ensure that there's a good performance for the thermal flux. The installation and the injection of the vacuum is auto monitoring by the computer. Besides, we also can manual control so that we can alert the progress of the machine. So the picture show that the vacuum injection machine that normally used in the industrial for the manufacturing of bottles. So comes to the machine ownership and cost maintenance. Based on our research from the catalog, we have a price for those two machines. Hydroforming machine costs 515,952 ringgit, and vacuum injection machine costs 48,000. So they have their own rental fees about 2,000 and 2,500, and then their maintenance fees will be 500 and 800 respectively. So this table shows that the cost and maintenance fees for the machine that we use during the flux manufacturing process. Thank you. Thank you.
My name is Wang Xunjie, and now I will proceed to the estimation of total cost per unit. For the fixed cost of this product, there will be factory rental, machine rental, machine maintenance fees, and labor cost. For the factory rental, the cost will be 7,500 ringgit. For the machine rental will be divided into two. For the maintenance fee will be 1,300. For the labor cost, there will be one maintenance engineer, one production engineer, 20 workers, and 3 admins. The total cost for the fixed cost will be 43,700. For the variable cost, we will select the material from 3 suppliers. Total cost for variable cost for the supplier A will be 65 ringgit and 20 cents. For supplier B will be 108 ringgit. And for supplier C will be 71 ringgit. The total cost for the supplier 1 is equal to 43,700 plus 65.2 quantity. For the total cost for supplier B will be 73,700 plus 108.20 cents times quantity. For the total cost for supplier C will be 43,700 plus 71.2 times. For the determination of sale price and break-even, the existing market price for the thermal flux is 50 ringgit to 120 ringgit. So we will select the sales price for our product will be 160 ringgit per unit. For the break-even analysis, total return equal to total cost. The total return will be price times quantity, and the total cost will be fixed cost plus variable cost times quantity. There will be 3 conditions. Condition 1 will be material get from the supplier A, and condition 2 will be material get from the supplier B, and condition 3 will be material get from the supplier C. That's all for me.
My name is Qin Chen. So for the profit margin part, we use the formula total sales minus total cost over total sales times 100%. And then you use this formula applied to condition 1. So we substitute the Q equals to 1,000 unit, and we obtain the profit margin for condition 1, which is 31.94%. And then we use the same formula applied to condition 2 and 3, and we have the answer as shown in this table. So for condition 1, the profit margin is 31.94%, condition 2 is 5.06%, and condition 2 is 28.19%. So from these 3 parameters such as the total cost, break-even, and also the profit margin, we can see that the condition 1 have the lowest Q, break-even Q, and also the highest profit margin. So which means that this condition 1 is the ideal condition for our project. So we choose supplier A as our main supplier to supply the components for our project. So next, I'm going to present the work breakdown structure. This company, we have 5 important characters, such as the general manager, service manager, maintenance manager, production manager, and also marketing manager. So in each character, they have their important jobs, such as the general manager involved in the management of the whole company. So the job for the general manager is basically to make sure every flow of the company is going smoothly. So for the marketing department, this department is in charge of promoting the product and also the company through social media and also the advertisement. The production department involved in planning the process and also the coordination, as well as make sure that all the manufacturing process is is done. The maintenance departments involved in the installation, the repair, and the inspection of the products. Service department is involved in the scheduling and the monitoring of the after-sales service, and also training the new employee. In this Gantt chart, there will be two color, the blue color and also the orange color. The blue color represent the planning, and also the orange color represent the actual process. So in week 3, what we have done is the chapter 1, the introduction, such as the company profile, vision and mission. In the next week, we plan to do the chapter 2, which is a business proposal, but we use 3 weeks to complete the chapter. So next, we start doing our chapter 3, which is the product cost and profit analysis from week 6 to week 8, which also takes 3 weeks. And we complete our chapter 4, which is the time allocation of project, in week 8 in total. For the next part, which is chapter 5, financial planning, we plan to complete in week 10, but we complete in week 11, same as to the conclusions. So from this Gantt chart, we can say that we already done our job in week 11. So that's all for my part. Thank you.
Hi, Doctor. My name is Wong Hui Yin, and now I'm going to present about financial plan. So in our project, the financial plan is used to determine the appropriate monthly installment that involve in production of the product and reduce the unnecessary expenses for the product. We assume that we will produce 600 of reheatable thermos flasks that in a month. So we calculate the profit by just now the formula have been told before. Then we just substitute the 600 into the Q, so we get the profit per month will be 13,180 ringgit Malaysia. So our profit per year will be 158,160 ringgit Malaysia. This is the profit that we gain for year. So we want to calculate the present cash that we will the money that we borrow from the bank. So we take from the table that our interest rate will be 4% per year. So from the table, we get that P over F is equal to 0.8219, and we put into the formula. So we will get that we want to borrow the money from the bank will be 130,000. So we assume that we need to pay back the loan to the bank for within 5 years. We substitute the value into the formula, so we get the annual cash that we need to pay back for the bank per year. So per year we need to pay back for the bank will be 29,000, and for per month we need to pay back to the bank will be 2,433 ringgit Malaysia per month. So this will be the cash flow for the per year. So we want to know that whether our product will be profitable or not profitable. So we use this present worth method. So if it is less than 0, so it's non-profit. If it is 0, is present worth is equal to 0. It means that we didn't have any loss or gain. But when the present worth is more than 0, it means that our production will be gained. So for the first year, our present worth that we calculated will be 258,000, which is bigger than 0. It means that in the first year that we will have gain and profit. And for the second year, the present worth that we calculate is 387,000, which is larger than 0 also. So it means that we also gain in this year. So for the third year, fourth year, and fifth year, so the present worth is really bigger than 0. It means that our production is profitable. So that's all from me. Thank you.
In conclusion, the objective is achieved, which is we are able to design the thermos flask, which is able to heat the water to the maximum temperature of 80 degrees Celsius and also to maintain the temperature of the water. Besides that, after the calculations, we found that the fixed cost required is about 43,700, which includes the rental fees and the labor cost. In addition, the selling price is about 160 ringgit and the profit gains is about 31.94%. Furthermore, we also done the forecast expenses payment, which the profits per amount is about 158,160 ringgit. And for lastly, the equivalent worth of the future cash flow, we are able to make a profit after 5 years. That's all from our group. Thank you.